Now, yesterday we started with how to integrate an 1 over u or 1 over x. We said that the integration for 1 over u is ln of the absolute value of u plus c. And we solved these examples. And we say that if you find that the denominator, like here, if you find the denominator here, like x cubic minus 9, and its derivative is on the numerator, so if you find here is the denominator, and here you find the derivative of the denominator, so the integration of it will be ln of the denominator plus c. So here now, do you see the screen now?
Yes.
Okay. Then, if you have now like for here now, for this one, you have 27x squared over 9x cubic minus 7. So, as you see, the first step, we have to assume that this is u. So, assume that u is 9x cubic minus 7. So, if u is 9x cubic minus 7, the second step, you have to find du over dx, which is 27x squared. Then, by cross product, du will be 27x squared dx. Then, so not 27. So 27x squared dx, I can replace it with du over 9x cubic minus 7, this is u. This is the integration of du over u. And then, as I told you, the integration of 1 over du will be ln of u plus c. And then replace u with 9x cubic minus 7. So ln of 9x cubic minus 7 plus c. This is now if you have an rational expression as an one expression over as a quadratic expression over a quadratic expression, how we deal with it. Now, sometimes you have example like this. Integration of 3x squared minus 9 over 7x. Let's assume that this is u. So u is 3x squared minus 9. So du over dx will be 6x. So du now is 6x dx. But I don't want, oh, there's no 6x. So I will replace it only with x. So let's say that du over 6 is x dx. Why I made this step? Because here there's no x, oh, there's no 6x dx. There's 7x dx. So what I have to do, I have to say that this is that x dx is du over 7. So I will replace x dx with du over 7 over 6, sorry. and 3x squared minus 9, I will replace it with u. Then let's now rearrange it. We have it as 7 over 6, the integration of 1 over u du. Then the integration of 1 over u is ln u. So I will say it is 7 over x ln u plus c. So 7 over 6 ln. Now, so I will replace u now with 3x squared minus 9 plus c. This is now the integration of 7x over 3x squared minus 9. Is it clear?
Yes, teacher. Yes.
Yes, teacher.
No. Let's talk about the trigonometric ratios and the integral of the trigonometric ratios. We say that the integration of cosine is sine x plus c. The integration of sine is negative cosine. The integration of secant squared is tan. The integration of secant tan is secant. The integration of cosecant cotan is negative cosecant. And the integration of cosecant squared is negative cotan. So we know what is the integration of cosine, what is the integration of sine, what is the integration of secant tan, what is the integration of secant squared. But we don't know what is the integration. So if I give you as an example, integration of tan, what is the integration of tan? It's not here. There's an integration of secant tan. There's an integration of secant squared, but there's no integration for tan. So what we have to do? Let's now solve it here by ln. Now, today we will learn how to find the integration of tan. Let's rewrite it now. As we know in algebra 2 that tan is sine over cosine. So instead of tan now, write it as sine x over cosine x dx. So let's find it as the integration of sine x over cosine x. Then let's suppose that this is u. So if this is u, then du will be. Now what is the integration? What is the derivation of cosine? Negative sine. So du over dx will be negative sine x. So du is, or negative du is sine x dx. Now let's replace sine x dx with negative du over u. Then here, as you see, we have negative 1, the integration of 1 over u du. Now, what's the integration of 1 over u? Ln u, absolute value of u plus c.
U plus c.
Exactly. So it's negative 1 ln u, where's u? Is cosine x plus c. So when I asked you what is the integration of tan, you have to say it's negative ln cosine of x plus c. This is now the integration of tan, negative ln cosine x plus c. Is it clear?
Yes, teacher.
Now, let's find the integration of cotan. For the integration of cotan here, we know that the cotan is 1 over tan or cosine over sine. So let's write it as cosine x over sine x dx. So let's rewrite cotan as cosine over sine. Then we assume that this is u. So if u is sine x, so du over dx will be, what's the integration of sine? It is
Cosine.
cosine. So du over dx is cosine. So that's mean du is cosine x dx. So let's replace cosine x dx with du. So I have it as du over u. So this, I have it now as the integration of du over u. So it is integration of 1 over u du. And all of us know that the integration of 1 over u is ln lu plus t. So it is ln cosine x plus t.
Yes, sorry.
Sorry?
Yes,
Sine,
sorry.
sorry. Sorry. Sine. My mistake. So the integration of cotan is ln sine x plus c. Is it clear?
Yes, teacher.
Yes, teacher.
Let's have now, or let's do these examples here. Y equal ln tan x. Here now, let's wait a minute. I want to see what I want to do. I think you have to find the derivative, but let me check first. Yes, find dy over dx. Now here you have to find the derivative. So find dy over dx. Now let's remember, when I told you ln, when you want to find the derivation of ln u, you have to say it is 1 over u times du over dx. So here we have it as ln. So y now ln tan x. So let's say this is u, and if this, I will just assume that tan is u. So if u is tan x, so du over dx will be, what's the derivation of tan? Secant squared x. Yes. So u is tan and du over dx is secant squared. Then, so dy over dx is 1 over u, which is 1 over tan x, times du over dx, which is secant squared. So the integration here will be secant square x over tan x. Let's now, if you write it like this one here, it's true. Let's now try to simplify it here. Secant is 1 over cosine squared. And tan is sine over cosine. So that means it is 1 over cosine squared times the reciprocal of this one, which is cosine over sine. So cosine, cancel cosine, we have it as cosine. So the final answer will be 1 over cosine x times 1 over sine x. So this is the answer, this is correct, and this is also correct. As 1 over cosine times 1 over sine. Is it clear?
Yes, teacher.
Now some of
Yes,
you
teacher.
say, teacher, I need to write it as ln of sine over cosine. Can I solve it? Can I get the same answer? Let's see. Here we have it as expanded since it is divided. So I write it as ln sine of x minus ln cosine of x. Then ln sine. What do you have to do? It is 1 over u, 1 over sine, times the integration of sine. What is the integration of sine?
Cosine.
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 Minus 1 over cosine times the integration of cosine, which is negative sine. So I have the answer as cosine over sine minus or plus sine over cosine. So by cross product here, we have cosine squared of x minus sine squared of x over sine x cosine x. Then now let's remember here. I will say that the answer was 1 over sine times 1 over cosine. لا not minus, plus, sorry. صح؟ yes, plus. Cosine squared plus sine squared is 1 over sine x cosine x. Since sine plus cosine is, as we said before, cosine squared plus sine squared is 1. So I can replace it with 1 over sine x cosine x. And we get the same answer. So if you solve it by expansion or you solve it by the u substitution, you must get the same answer, and any of them will be correct.
Teacher,
Yes.
can I keep it as cosine squared x plus sine squared x?
You mean like this?
Yeah.
Yes, yeah, you can. But I just, yeah, you can keep it like this. I just here to write how to prove that you get the same answer. And you can keep it as secant square over 10. Like what I did before.
Okay, teacher.
Okay. Is there any question?
No, teacher.
Now
No,
let's solve
teacher.
number 23. In number 23 here, y is cosine ln x. And then you need to find its derivative. Now, do you remember the chain rule? That's when we say if we have cosine x squared plus 1 as an example. The first step, you find the derivative of what is inside times the derivative of what is outside, which is negative sine x squared plus 1. So you will say it's negative 2x sine x squared plus 1. So in chain rule, you find the derivative of the outside, then the inside, or the inside, then the outside. Here we have to do the same because it is cosine ln x, not cosine x. So I need to go now to use the chain rule. Then, so it is, you have to find the derivative. What is inside? What is the derivative of ln x?
1 over x.
1 over x. Now, after I find the derivative of inside, I have now to find the derivative of the outside. Now, what is the derivative of cosine?
Negative sign.
Negative sine ln x. So, I get the answer as negative sine ln x over x. Is it clear?
Yes, teacher.
Yes, teacher.
Let's solve now. So this is cosine ln x. Now what about now? Like number 22, ln cosine x. The first one, it was cosine ln of x. You have to use the chain rule. But if you have ln cosine x, no, you have to go to use the u substitution. That assume that this is u and du over dx is sine or negative sine lx. So it is 1 over u, which is cosine x, times du over dx, which is negative sine lx. So it will be negative sine x over cosine x, which is negative tan lx. So the derivation of ln cosine is negative tan x. And that's mean, as we said before, that the integration of ln cosine of x is negative tan x. And the integration of negative of ln of cosine is tan, and of negative cosine is negative tan. And the integration of the integration of ln sine of x will be not integration. I'm sorry, this is the derivative. I'm sorry. I'm so sorry, this is a derivative. So by now, we say that the derivative of ln cosine is tan. The derivative of ln in negative cosine is negative tan. And for the ln of the sine, it will be cotan x plus c. I think it is the opposite. This is negative and this is positive. So the integration, the derivation of ln cosine is negative tan, of ln negative cosine is tan, and of ln sine is cotan. That's it. By now we finished our second lesson, which is lesson 6.2. Tomorrow, inshallah, we are going to start with how to find the derivative of inverse function of integral for the exponential function. Like if you have, what is the integral of p of x? I mean, like if you have 3 to the power x, what is the integration of it? Or what is the derivative of 3 to the power x? We talked about ln, logarithm. Inshallah, tomorrow we are going to talk about how to find the derivative of the inverse function. In lesson 2, we talk about the logarithmic function. In lesson 3, we talked about, inshallah, the inverse function.